Okay, let's just jump right into it. We are living in, well, a fire hose of information.
Wow, absolutely.
And a huge amount of that water spray is, frankly, disinformation. It's gotten way more complex than just, fake text headlines, too.
Yeah, definitely.
Now we see it mashed up with images, what the research we're exploring today calls multimodal disinformation.
It's true. And the stakes are incredibly high. This kind of combined text and image lie isn't just annoying, it actively undermines societal trust,
Right.
makes it harder for you to make informed decisions in your own life, and can even have national security implications.
Yeah, I remember all the stuff during the pandemic.
Exactly. Think back to the torrent of false claims about COVID-19. Many involved images or charts paired with, misleading text.
Exactly. Stuff like this herb cures it with a picture of the herb, or some weird graph claiming masks don't work. Real world harm from digital fakes.
Hmm.
So the crucial challenge then is, can we build automated systems, AI really, that can keep up and effectively detect this increasingly sophisticated multimodal deception?
And that's precisely the central question tackled by the paper we're doing a deep dive on today. It's a piece of recent research titled Holmes, Automated Fact Check with Large Language Models.
All right, Holmes, sounds promisingly investigative. Our mission with this deep dive is to take this specific research paper, unpack it, and get straight to the good stuff for you.
Right.
We want to understand how the current generation of powerful AI, large language models or LLMs, performs at this fact-checking task right now,
Huh.
um, identify their major blind spots based on the paper's findings.
And see how this new framework Holmes proposes to solve those problems, especially by getting smarter about finding reliable evidence. That's the key, really.
Finding that evidence. So the paper starts by looking at the landscape, right? What came before.
Yeah, so you've had traditional methods for fact-checking, often relying on specific patterns, but they really struggle with new formats and don't adapt well. They break easily when disinformation evolves.
Right, they're too brittle. And then LLMs come onto the scene, these incredibly flexible systems that seem capable of understanding and generating just about anything. There was a hope, I imagine, that they could just handle fact-checking out of the box.
Well, they certainly bring impressive reasoning and processing power, but the researchers wanted to really test this, specifically for multimodal fact-checking. So they ran an empirical study using state-of-the-art LLMs to see what happened when presented with these complex claims.
And the results weren't quite the magic bullet some might hope for, were they? The paper highlights three key findings from this initial test. What's the first big takeaway?
Okay, so finding number one, LLMs, even using techniques like chain of thought, where the AI is prompted to sort of show its step-by-step reasoning, really struggled to verify claims accurately, solely based on their own internal training data or just the claim itself.
So they can't just access some giant internal encyclopedia and know the truth, like instantly.
Not reliably, no, especially for recent events or highly specific claims. The paper gives examples, like in Figure 3. There's a claim about scenes from Sheikh Hasina's bedroom with an image.
Okay.
Or the text claim, Kevin Costner refused to be on the same stage with Whoopi Goldberg. When just given these claims, the models often just defaulted to saying they couldn't verify it
Why not?
because they simply lacked the necessary up-to-date information. Their knowledge has a limit, a cutoff point.
Okay, so relying just on the LLM's internal knowledge isn't enough for the constantly changing world of disinformation. That makes sense. What if you try to make the LLM more active? Maybe get it to use tools to look things up.
Ah, well, that brings us to finding number two. The study found that even when you integrate LLMs into a fact-checking process and try to get them to search the open internet for evidence themselves, they were often unreliable.
Unreliable how? You'd think a model that can generate complex text could handle a web search. Seems simple enough.
Yeah, you'd think. But they ran into two main problems. One, they sometimes generated potentially hallucinated evidence. They'd just make up plausible-sounding information that wasn't actually real.
Oh, that's bad.
Yeah. And two, and just as frustrating, they'd generate links to websites that were inaccessible or simply didn't contain the information they claimed. This completely erodes any trust you might place in their final verdict.
Right, if the source link is dead or irrelevant.
Exactly. Look at Figure 3 again in the paper. Examples like the Kimberly Cheadle arrested claim show the LLM referencing links that didn't work, making you wonder if the whole justification was just fabricated.
Okay, so they can't be trusted to find good evidence on their own. This raises a pretty significant problem. and maybe points towards where a solution might lie.
Absolutely. And this is finding number 3, which I think is the most important insight from their initial study. The researchers discovered that when they provided the LLMs with high-quality, human-written evidence, accurate information pulled from reliable fact-checking sites or credible sources, the LLM's performance dramatically improved.
Whoa, how dramatic are we talking? Like a little bit better or
Oh, very dramatic. When given this reliable evidence, models like GPT-4o and Gemini 1.5 Flash saw their success rates jump to over 90%.
90%? Wow.
Compare that to the very low rates they achieved when trying to rely on internal knowledge or their own flawed search attempts, as detailed in Table 2 of the paper.
That's a huge jump. It really highlights that the LLMs can reason, they can process information and structure justifications, but they are critically dependent on getting reliable external data fed to them.
Precisely. It's not that the AI lacks the logic, it lacks the reliable inputs to apply that logic too. Now, they still noted minor issues, even with human evidence, like occasional small hallucinations in summarizing, but the core capability was unlocked by providing quality information.
Okay, so the big lesson from the study is clear. LLMs need high-quality evidence to fact-check effectively, especially with these tricky, multimodal claims. But human fact-checkers providing evidence isn't automated or scalable. That's the bottleneck. So how does the paper propose to bridge this gap automatically?
And that's where the Holmes framework comes in. Built directly on that crucial, finding 3, the absolute need for reliable evidence, the paper introduces Holmes as an end-to-end system for automated multimodal fact-checking.
And the secret sauce, the core innovation here, is it just better search?
It's more than just search. The core of Holmes is a novel methodology specifically for evidence retrieval and evaluation. Its job is to automatically go out, find information from the vastness of the public internet, judge its quality and relevance, and then package up the best evidence to feed to the LLM for verification.
So it's automating the critical evidence finding and vetting step that the LLMs themselves failed at. What are the claimed advantages of Holmes over those earlier methods or just basic LLM attempts?
The paper highlights several. First, it uses off-the-shelf LLMs for the reasoning part. You don't need expensive fine-tuning or retraining of massive models, which is a huge plus.
Okay, more accessible then.
Right. Second, by automating the evidence search and verification, it enables rapid, near real-time fact-checking, which is essential when disinformation spreads instantly.
Speed is definitely crucial.
And third, it provides detailed, explainable justifications for its verdicts, pulling directly from the evidence it found. This helps build trust in the system, you know. You can see why I made the call.
Transparency is definitely key with AI systems. Let's take a look under the hood then. How does this Holmes framework actually work, step by step?
Sure. You can see a nice overview in Figure 4 of the paper. It starts when a multimodal claim comes in, let's say a piece of text paired with an image, like we discussed earlier.
Got it. What's the first thing Holmes does with that?
Step 1 is claim decomposition. Holmes intelligently breaks down that combined claim into its separate components: a text subclaim and an image subclaim.
Logical. Address each piece. And then comes the really critical part based on finding 3, evidence retrieval. How does it do that better?
Exactly. This is the heart of Holmes's innovation. It uses standard tools, initially text search engines for the text claim, and image reverse search for the image. This finds potentially relevant web pages, standard stuff so far.
Okay, so far standard. What's different about how it handles the results? It doesn't just pass the links on.
Right. Once it has links, it extracts the main content from those pages. It's designed to focus on the core article content and ignore noise, like ads or footers. And if a page is down or blocked, it can even use the snippet the search engine provides as a fallback, which is pretty neat.
Still sounds like good web scraping. Where does the AI get really clever in the evidence step?
Okay, here's a big innovation. It uses an LLM specifically to summarize the key points from the extracted content, but not just any summary. It guides the LLM to look for and extract 8 specific elements.
8 elements. What are they?
Things like who is involved, what is the core event, where did it happen, location, when, time, why did it happen, reason, what's the background context, what's the impact, and what's the follow-up. This structures the information into usable snippets of evidence.
Ooh, that's smart. It's not just grabbing text, it's actively structuring it and pulling out the most important factual details for the verification step, like building a little fact sheet.
Exactly. It's pre-processing the information into a useful format. And here's the other big innovation in this step. It evaluates the quality of the evidence it finds using new metrics. It assesses credibility, relevance, and integrity.
How does it measure those? That
Yeah.
sounds tricky to automate, credibility especially.
Yeah, so credibility involves checking sources against blacklists of known unreliable sites, but also using a machine learning model trained to assess the general trustworthiness of the web page itself.
Okay, so it's got some intelligence there. What about relevance and integrity?
Relevance measures how closely the content of the summarized evidence aligns semantically, like meaning-wise, with the original claim. And integrity assesses how completely the summarized event information captures those 8 key elements we talked about, basically. How comprehensive is this piece of evidence?
Gotcha.
Holmes then ranks the evidence based on a combination of relevance and integrity, but only if it passes a certain credibility threshold.
So it's finding relevant information and checking if it's from a trustworthy source and making sure the summary is complete and useful. That's a lot more sophisticated than just handing raw search results to an LLM.
Much more.
Okay, so it's gathered and ranked the high-quality summarized evidence. What's the final step? Making the call.
Step 3. Verification and justification. Holmes sends the original claim along with the top-ranked, high-quality summarized evidence to the main verification LLM.
Ah, feeding the LLM precisely what it needs, fulfilling the promise of finding 3, but doing it automatically. Very neat.
Correct. It guides the LLM through a structured process. The paper simplifies various common fact-check labels, like mostly true, partly false, into a straightforward true or false verdict system, as shown in Table 3.
Keeping the final output clear and simple. Good.
Yes. And then the LLM generates a detailed justification for its verdict. This is crucial. It explains why it arrived at that true or false decision, citing the specific pieces of evidence it used from the summarized content. This makes the whole process transparent and verifiable.
Let's make this concrete with an example the paper uses. I think Figure 5 shows the claim about Australia declares George Soros a global terrorist. That definitely sounds like the kind of multimodal claim you see circulating online.
It is a classic example, and it includes that text claim paired with an image of George Soros. Holmes would process this.
Okay, walk me through how Holmes would handle that specific one based on what you've described.
All right, so Holmes would first decompose the claim into the text part and the image part. It would initiate searches for both. For the text claim, it might find articles or, ideally, official government pages. The paper shows it potentially finding the Australian National Security website as a source.
Which sounds like a very credible source for that kind of information. Definitely what you want.
Exactly. Holmes would then extract and summarize the relevant content from that official site, specifically pulling out details related to how Australia lists terrorist organizations, perhaps mentioning the relevant laws like the Criminal Code Act 1995, as shown in the example extraction in the figure.
Getting the specific legally grounded context, not just a random opinion piece.
Right. It then evaluates this extracted summary. The example in Figure 5 shows it calculating an evidence quality score, maybe 0.45, for that specific piece based on its credibility, relevance, and integrity. This evidence would likely rank highly because it's from an official source and highly relevant to the claim's substance.
And then it passes as high-quality evidence, the summary from the official site to the LLM for the final call.
Precisely. The verification LLM receives the original claim, and this summarized evidence from the Australian National Security site. Based on that evidence, which would state that Australia's legal framework only allows listing organizations, not individuals, as terrorists, the LLM would verify the claim as false.
And the justification would then connect directly back to that specific piece of evidence.
Absolutely. The justification would explicitly state something like, based on information from the Australian National Security website, Australia does not have a legal mechanism to list individuals as terrorists, confirming this claim is false. It directly shows the evidence behind the verdict, makes it trustworthy.
That process feels very robust, logical.
Yeah.
But the proof is in the pudding.
Right.
How well does it actually perform when put to the test across different scenarios?
Good question. The researchers did extensive validation. They tested Holmes on multiple datasets, 2 existing ones, Mocheg and MR2, which already had pre-provided evidence.
So testing how well it uses evidence first.
Exactly. And also on a new one they created, MMDV, specifically designed for real-time claims where Holmes has to perform the evidence retrieval itself, the whole end-to-end process.
Okay, what were the headline results? Did it work?
So when using datasets with pre-provided evidence, like Mocheg and MR2, Holmes generally outperformed traditional baseline methods, demonstrating its ability to effectively use good evidence when it's given. That's shown in Table 6.
Okay, good start. And transferability. Can it handle claims beyond what it might have initially seen during development? That's often a sticking point.
Crucially, yes. The paper shows it has strong transferability to new domains and datasets without needing retraining, which is a huge practical advantage compared to those older, more rigid baseline models. Table 7
Uh,
covers that.
okay, that's promising. But the real test, based on the struggles we talked about in Finding 2, is how well it does when it has to find the evidence itself. What happened on that MMDV dataset?
This is where Holmes really shines and validates its core approach. On the MMDV dataset, where the system has to perform the entire process, including finding and evaluating evidence, Holmes, with its novel retrieval method, achieves significantly higher accuracy than methods that couldn't retrieve evidence or used less sophisticated retrieval. That's in Table 8.
Significantly higher. How high are we talking? What kind of accuracy numbers?
The accuracy rates for Holmes were pretty impressive: 90.2% for GPT-4o and 87.0% for Gemini 1.5 Flash.
Wow, compared to what, roughly, without the smart retrieval?
Much lower. It shows a massive leap from the struggling performance we saw when the LLMs tried to find evidence on their own or with simpler methods.
So the intelligent evidence retrieval and evaluation piece isn't just important, it's basically the breakthrough enabling the LLM to succeed at this task automatically.
Exactly. And they confirmed this with something called an ablation study. That's an experiment where they systematically tested different parts of Holmes by removing them to see exactly which components were driving the performance boost.
Isolating the key ingredient.
Precisely. The ablation study, Table 9, confirmed that Holmes's specific method for retrieving, summarizing, and evaluating evidence was the primary reason for its superior performance compared to previous retrieval methods or just using the LLM search capabilities.
So it's not just having an evidence step, it's having Holmes' specific smart evidence step that makes the difference. Okay, so given what it does now, focusing on text and images, what are the current limitations or blind spots this paper identifies? Where does it still fall short?
Yeah, so based on its design and the data sets used for validation, Holmes currently focuses squarely on disinformation presented in text and images.
Okay, so it can handle a fake news story with a manipulated photo, which is common. But what about other formats? Video, audio.
It can't handle disinformation embedded purely in audio or video content. The paper explicitly calls this a critical blind spot in current research.
Which is a big deal, right? So much stuff online now is video.
A huge deal. A lot of misleading content today comes in video or audio formats. Think deepfakes, selectively edited clips, misleading sound bites. Current systems, including Holmes, which relies on text and image processing, really struggle to verify claims where the crucial information or manipulation is in the audio or visual sequence itself, not just accompanying text or a static image.
Like those deepfake videos or cleverly edited sound bites that pop up?
Precisely. And even the search-enhanced LLMs they tested still mainly rely on text analysis of transcripts or metadata, which doesn't help much when the lie is in the video or audio itself.
So what's the suggested future work based on these findings? How do we tackle that blind spot?
Well, the paper points towards integrating capabilities from emerging audio and video LLMs into frameworks like Holmes. The goal would be to extend this intelligent retrieval, summarization, and evaluation process to those other modalities.
So true multimodal fact-checking.
Right. For truly comprehensive fact-checking that covers how disinformation actually spreads today.
That makes sense. You need AI that can understand video and audio just as well as text and images. So let's bring this all together. What's the core takeaway from this deep dive for you, the listener, navigating the modern information landscape? What should people remember from this?
I think the fundamental insight from this research really is that tackling sophisticated multimodal disinformation automatically isn't just a matter of building the largest, most knowledgeable AI model. It's actually more about giving that AI system the robust capability to find, judge the quality of, and effectively use reliable external information in real time. The evidence part is paramount.
And the Holmes framework is presented as a significant step forward because it directly addresses that critical evidence gap with its clever retrieval, summarization, and evaluation process, basically ensuring the verification AI has the credible inputs it needs to make a good judgment.
Exactly. Tools like this offer a potential pathway towards making the digital information you consume more trustworthy, moving beyond opaque true or false verdicts to providing transparent, evidence-backed explanations for why something is flagged the way it is.
It really drives home that AI, however smart it seems, is only as good as the information it's given, and getting that information right, vetting it automatically, is a massive
It
challenge.
really is.
So here's a final thought to leave you with. If AI systems like Holmes can become highly effective at fact-checking complex, real-time information across all modalities, text, images, and eventually audio and video, how might that fundamentally change our relationship with the digital content we consume every single day? And, maybe more interestingly, what entirely new kinds of information challenges might that create that we haven't even